All right, so we're looking at our second example for the trig integration using substitution. And in this example, we have the two trig functions, secant squared of x, tangent of x. And I'm noticing that the x is not something that you'd want to substitute with a u because it's just a single variable. So in this case, we're going to let u equal the secant of x. And that way I can write u squared times du, okay? And it'll be easier to integrate it that way. So when I do my du dx, I get my derivative of secant of x is secant x tan x. So du is secant x tan x dx. So this is the previous example was when we substituted u where u was not a trig function, and in this example u is a trig function. And what you're really looking for is there a trig function with an exponent? That's not going to be the case 100% of the time, but from what I've noticed, it seems to be pretty common. So is there a trig function with an exponent? Let that function be u. Okay. All right, so in this case, we decided secant of x was going to be u. And du is secant x tangent of x dx. All right, so when I look at this, I need to have secant of x tan x dx as my function. And I've already kind of got it because I have secant of x squared, which we know is really, you could split that up into secant x, right? And then it's multiplied by tangent of x dx. So now I have my two parts. I've got my du, secant x tan x dx, and I have my u, which is secant of x. So now I'm going to integrate it with substitution. So I've got the integral of u du. The integral of u is 1/2 u squared plus c. And now I just put my secant back in there. So I have 1/2 secant squared of x plus c. That could also be written 1/2 secant of x squared plus c, but it is more normal, I guess, it is more common to write the squared between the secant and the x. So we have our answer. All right, so remember, if you have a trig function with an exponent and it is not something like this, but that is already easy to integrate, then you're going to let that function be u. All right, good luck.